Previously we built this quadcopter can fly 50-minute with double 21-700 cell. In this video, I will show you the process of how I completed this drone. Let's get started with the frame. I cannot find the ultralight frame for 5-inch, so I decided DIY a frame for myself from the arm of Darwin FPV Baby Ape 3. It's quite durable and just 15 gram. I grabbed a pack of 4 on sale for only $5. From one motor mount to the other, it's just 205 millimeters. Use superglue to bond them at 90 degrees with a 5 mm flat carbon bar. And finally, lock them in place with 2 mm screws. This is Darwin FPV 15-amp 3-in-1 flight controller. On my last build, those Axis Flying 1505 4800 kV motors just couldn't handle big props on 2S power. I kept getting desyncs and flyaways. That's why I went with the P1604 3800 kV. The wider stator and lower kV give it way better torque for swinging 5-inch props smoothly. I'm running this VTX here, with an output power of 1000 milliwatts. And for the camera, I'm using the CYCLONE. It's one of the best ultralight micro cameras. I'm going to be trying this lollipop antenna, but I had to resolder the cable a bit to fit the connector on the VTX. I'm using the Happymodel EP1 Dual TCXO instead of the onboard SPI receiver for much better signal sensitivity. I'm chose this GPS, it gets a satellite lock very fast and accurate. I built this 2S pack using Ampace JP30 cells, with 36 amp discharge. I've been using these cells on my 1S drone, getting up to 25 minutes of flight time. And with the bigger EVE 21750 PL cells, with 125 amp discharge rate, it gave us a huge 50-minute flight time in my previous video. To power the VTX, I added a DC boost module that bumps the 2S battery voltage up to 9 volts for a stable supply. I'm using UART1 for the receiver, UART2 for the GPS, and with this flight controller, the smart audio pad is set up as a soft serial port, so I don't waste any UART to control the VTX. Here is pin out of this flight controller. I twisted the connecting wires together, which actually helps cut down on signal noise a bit. Now we almost done, just gotta mount all these parts onto the frame, and the build is complete. This is the top plate I custom designed using an NFC card. It have the mounts to hold the antennas and GPS. It has a locking latch to keep the IPX connector from popping off. Here are my current settings in beta flight. This tune is not absolute perfection, but I did my best. For the video transmitter, I assigned aux 5 to a slider, allowing me to adjust the power level directly from my radio. Let's see how much weight of this drone. EVE 50PL 21700 is 135 gram. LG HG2 is 93.2 gram. Ampace JP30 is 101.8 gram. And the weight of this build is just 113.4 grams. And with 21702S battery is 248.4 gram. With JP30 just 215.2 gram. With LG just 206.8 gram, we have 42 gram for mounting a camera. Let's see how it flies. It managed to hit a top speed of 98 km per hour. We have a problem here, the video quality is pretty rough. As you can see on screen, there's just way too much noise. So instead of powering the VTX through a boost converter, I switched to direct battery power with an LC filter, and that completely fixed the issue. I'm living in the city, doing a proper long-range test is tricky. I tried pushing it, but hit a wall at 2 km on 100 mW power of transmitter. The LQ started dropping rapidly due to radio noise. So in this flight we're going to find out flight distance. Now we just crossed the 29-minute mark, and it's still fine. I will landing at 2.8 volts, that mean 5.6 volts on 2S battery. So we hit 31 minutes of flight time and covered a total distance of 17.5 kilometers. This means on a proper long-range run, I could push a 9-kilometer round trip, with a 2S18650 battery. Thanks for watching, see you in the next video.